time here. Okay, with this next part here, we're supposed to determine if they're similar. Remember, there's two things they have to do. All the sides have to be proportional, and all the angles have to match up. Well, let's look at the first one. Those are two rectangles. Do all the angles match up? Yeah. Congruent angles. Check. Now we have to make sure the sides are corresponding. So the cool thing, since it's a rectangle, I don't have to do 4 of these. I only have to do 2 pairs of these. But I do know that AB is to EF. It's the same thing as DC is going to be to HG. And that's 6 to 4, which gives me 3 to 2. All right? So that's going from the larger one to the smaller one. Now let's do the other side. Segment BC, because notice all the ones on top come from the same polygon, goes to FG. That's the same thing as going AD to EH, because we know opposite sides of parallelograms are congruent. That's 9 is to 6. Oh, that's 3 is to 2. Great. So it says determine whether polygons are similar. Yes, they are. Write the similarity ratio. Similarity ratio, 3 to 2. Write the similarity statement. Well, when you do similarity ratio, the similarity statement, the one on top should be the one that's named first. So I'm going to go rectangle ABCD is similar to rectangle EFGH. All right? So that's for the first one. Now on the next one, again, look, do I have 3 pairs of congruent corresponding angles? Congruent angles. Check. Now we have to check our pairs of corresponding sides, okay? I know AB goes with XY. And again, I'm going left to right, so the top one is going to come from the left. So that's 10 is to 5. Oh, that's 2 to 1. Let's go AC is to XZ. That's 12 to 6. Oh, look, 2 to 1. Can you guys guess probably what's going on here? We got BC is going to go to YZ. That's 14 to 7. Oh, look, 2 to 1. So are they similar? Yes, because all the congruent angles correspond, okay? And all the sides have the same similarity ratio. So yes, the similarity ratio is 2 to 1. My statement of similarity is going to be ABC is similar to triangle XYZ. Now remember, you can name yours in a different order as long as your vertices still match up. All right, what do you guys think so far? Not too bad? All right, good. Let's keep going. Now the same type of thing I got to do for here, for the next 2. Now here's the cool thing. I know those are equal and I know these are congruent. So that kind of helps me with my matching up. But let's do our pairs of corresponding sides. The angles I know will work. So we have segment MN goes to ST, and that's 5 to 3. Now I need to do the same thing with these other ones. So I go QM is going to go to RS. It's the same thing as 20 over 3 to 4. Well, I don't like it that way, so I rewrite it. When you divide by a number, that's multiplied by its reciprocal, and I end up getting 5/3 for my value. Well, that means that would go for my other pair of sides. So are they similar? Yes. The ratios are all 5 to 3. So yes, going left to right, the similarity ratio is 5 to 3. And my statement would be triangle QMN is similar to triangle RST. Now you could also say RTS and you would have been fine. The answer for this one is no, because corresponding angles are not congruent. So pretty straightforward on that one. Now you will see something like this on your quiz. It's one of those straightforward things you have to know. And I tell you right away, guess what? The 2 triangles are similar. So WXZ is similar to DFG. I tell you how they match. Then I want to know the similarity ratio from WXZ to DFG. Now remember, the one that is named first, its side has to come on top. I will always give you a pair of corresponding sides or a similarity ratio. Well, these 2 sides go together. I got WX goes with DF. So that's 4 to 6, which is 2/3. Now notice again, this is a similar ratio of DFG to WXZ. So now I'm going bigger to smaller. So the bigger one has to be on top. And you're going to get 3 over 2. They're just going to be reciprocals of each other. Now let's do quick calculations of angles to do our corresponding angle stuff. What's the measure of angle Z? That's right. should be 53 degrees. So I'm going to put the 53 here. What's the measure of angle G? That's right, 53 degrees, because they're corresponding. G and Z are the same value. Now what's the measure of angle D? Well, D corresponds with W, so D and W go together. Oh, that's 37 degrees. Now, I have two things I'm going to ask you for DG and I'm going to ask you for WZ. Actually, find WZ first. 3, 4, 5, Pythagorean triple. Now, someone says, that's a 6, 8, 10. No. The 6 and the 4 are the ones that are matching up, so it doesn't work. It had to be an 8 there if it was a 6, 8, 10. So I know that value is 5. What that does now is allows me to set up a proportion to solve for the missing side, which is DG. Now, I can do my similarity ratio, and I'm going to go from small to big. All right, so my similarity ratio from small to big is 2 is to 3, as small is to big, 5 is to x. Now cross multiply. 2x equals 15, divide by 2. X is equal to 15 over 2. And you're done. So that's my value here, 15 over 2, and it should be larger than 5, so it works out. All right, we'll get our last example here.